Testing. 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 A what? No. Testing. Good. Testing. 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 Testing.
Test.
Testing.
Test.
Testing.
Check. Test. Oh,
Okay.
I hear Ross. He doesn't need a mic. This is pretty low. A little higher. Check. Test. Test. Uno. There it is. That's. Oh. Check. Test. 1, 2. Test. Check.
Everybody. Sorry about that. We're getting started 10 minutes late. It's that proverbial technology problem. I think hell is just going to be a place. Welcome to our Skeptics Forum. How many people here in the live audience have never been to the Skeptics Forum before? Welcome. Thank you for coming. What this is going to be is Dr. Ross is going to do a 20 or 30 minute talk, and then the rest of the time until 12:45 we're going to be doing questions. That's a little bit of a change. It's the first time we're trying this. Rather than people just going to the mic right away, Dr. Ross is going to do a talk first, and then we'll start getting we asked you a couple of things. over there that has a lot of reasons to believe material and not process material specifically. This is sort of an extension of paradox classrooms and apologetics classrooms down in 25 and room 154, which is that's called paradox class. So let's say thank you to these people who brought the food: Nancy Akabushi, Lynella Maxwell, Maria Campbell, and Helen Smith. Like I say, we're going to 12:45, not 1 o'clock. We have to wrap up for the day. Also, tomorrow night, we're having a Q&A called Reasons Forum. So that's at Reasons to Believe from 6:30 to 8 this Thursday night.
1960s, but they didn't analyze the data till the 1990s, actually the year 2000. And they finally discovered, wow, there's something in these deep sea cores that shows something we weren't even looking for. And basically what they discovered was evidence that a huge asteroid hit the Pacific Ocean off the southern tip of Chile. And they found debris scattered over about 30,000 square miles of the ocean floor. Now this is a place where the ocean is 17,000 feet deep. And so there was no crater. Basically, this asteroid, when it hit the water, made a really big splash. But they found bits and pieces of meteorites literally scattered over 50,000 square kilometers of the ocean floor, which told us that the asteroid was about a mile in diameter. So this is a really big meteorite that crashed into the ocean. And the impact was it generated tidal waves 1,000 feet high. And they've actually found evidence for the splash of debris on 4 different continents as a result of these 1,000-foot high tidal waves crashing into Asia, Australia, North America, and South America. Now what's recent is they've come up with an accurate date for when this asteroid hit, namely 2.58 million years ago. Now, what's significant about that date, that was the beginning of our Ice Age cycle. The only time in the history of the Earth we've had an Ice Age cycle has been the past 2.58 million years. And what I mean by an Ice Age cycle, where a planet cycles between having 10% of its surface covered with ice and about 20 to 23% of its surface covered with ice. But if it wasn't for this collision event, we would have no ice on Earth at all. Because right now the sun is so bright that it's extremely challenging for a planet to have any ice. And astronomers and geophysicists a year ago were thinking what brought about the ice was the movement of Antarctica to the South Pole, Greenland towards the North Pole, the joining of North and South America, and especially the collision of India into Asia. All those tectonic movements were cooling events. But we now recognize there would have been no ice forming over any of the continental land masses if it wasn't for this collision event. Because what it did is it not only caused this enormous splash, it sent up huge amounts of water vapor, salts from the ocean, sulfur from the bottom floor, and basically created a dense cloud over the entire Earth. And there are 2 effects of that dense cloud. Number 1, it blocked out the light of the sun from coming into the surface of the Earth, and that had a dramatic cooling effect. The other thing was the top of the cloud reflected away sunlight. So by 2 different mechanisms, there was a dramatic cooling of the Earth, and it's because of that dramatic cooling, ice was able to form over Antarctica, Greenland. That's when you got the polar ice cap forming, and especially that's when you got a huge amount of ice forming over the Himalayas and the Tibetan Plateau. That was particularly critical because those are regions that are close to the equator, where the reflection of sunlight to outer space is 4 times more efficient than the reflection of sunlight off of the ice of Greenland or Antarctica. Bottom line, there'd be no ice today unless that happened. I won't go into the details, but one of the books we're giving away is this one, Improbable Planet, where we describe 10 critical benefits from an Ice Age cycle. Bottom line is there's no way we could grow enough food for billions of human beings unless we were living in an Ice Age cycle. We need the water from the leftover ice from the last Ice Age cycle, and the Ice Age cycle also regularly fertilizes by 2 different ways the great agricultural plains of the Earth. Now what happened when this collided with the Earth, it ignited an Ice Age cycle that was driven by the variation in the tilt of Earth's rotation axis. As you know, it's about 23.5 degrees, but it varies very slightly from 22.1 to 24.5 degrees. And it moves back and forth like that with a period of 41,000 years. And from 2.58 million years ago to 800,000 years ago, it was that variation, that 41,000 year period variation, that drove the Ice Age cycle. Because when you tilt the rotation axis over more, that warms the planet. When you tilt it back up, that cools the planet. And that's what drove the cycle of 10% ice to 20% ice. The problem for human civilization, though, is a 41,000 year period gives you far too brief of an interglacial. Interglacial being that time when you only got 10% coverage. And with a 41,000 year cycle, you wind up with an interglacial that's shorter than 4,000 years. That's not enough time to launch and sustain high technology global civilization. But what astronomers have discovered, and again very recently, is there was a second asteroid collision event, one that hit the Spratly Islands. You've probably heard that there's about a half dozen nations that are all fighting for sovereignty over these little tiny islands in the South China Sea. What we now know is they were not tiny islands a million years ago. They were big islands, but an asteroid smashed into them and turned them into really tiny islands. And that little red dot you see there, that's the minimum crater size. That blue circle is the maximum crater size. So you can see this is a significant event, crater between 40 and 100 kilometers across. And what this did is it sent up a debris cloud into the solar system that we pass through about once every 100,000 years. And that, together with a 100,000 year cyclical variation in the eccentricity of Earth's orbit, changed the Ice Age cycle from a 41,000 year periodicity to a 100,000 year periodicity, which means we now have interglacials that last 10 to 12,000 years, which means we got enough time to launch and sustain civilization. Now, the last 4 ice ages look like this. This is from a deep ice core in Greenland and also from Antarctica. And it shows you the temperature variation, the global mean temperature over the past 400,000 years. And so you can see that 100,000 year periodicity there. But what I want you to notice is that it starts with the temperature rising very rapidly. And it goes up to a peak that's about 3 degrees centigrade or 5 degrees Fahrenheit above where it is right now. And when it hits that peak, it rapidly drops back down into an ice age. And we now understand why. When you warm the planet up about 5 degrees Fahrenheit warmer than it is now, it melts the polar ice cap. And when you melt the polar ice cap, instead of 60% of the sunlight being reflected off of the Arctic Ocean, only 6% is reflected away. What happens to that extra solar heat? It gets absorbed by the open Arctic Ocean water, which means you get a whole lot more snow falling on Canada and Siberia. And yeah, you're warming up Canada from 50 below to 40 below. But at 40 below, you're still going to get snow. It's not going to rain. And what happens is when you warm up Canada and Siberia, you wind up packing it with a lot of snow. And once you got Canada and Siberia covered with snow and ice, that reflects away sunlight with 60% efficiency, which drops the temperature of the entire planet by about 24 degrees Fahrenheit. And that's what brings on the Ice Age. Now, that did not happen in the previous Ice Age. What you see here at the end of this graph is the temperature was going up, but it didn't go all the way up to where it normally goes. And what you have is the tilt of our rotation axis going down to 24.5 degrees. That rapidly warms up the planet, but an event happened that stopped our Earth from going up to that high temperature. And we've known about this for some time. It's called the Younger Dryas cooling event. What's brand new is we discovered the cause of the Younger Dryas cooling event. This was published just a few weeks ago. Basically, they found a third asteroid crater site, and it's in northwest Greenland. That little tiny red dot that you see there at northwest Greenland, that's about the size of the crater. And the reason why they've only discovered it recently, because this thing hit just 12,800 years ago. So it's really recent. And you think, how can you hide a crater that big, that recent? Well, it was under 3,000 feet of ice, which explains why it wasn't discovered literally until weeks ago. But when that hit, again, it caused a dramatic cooling of the planet, such that this is what the recent temperature of our planet Earth looks like. This is the global mean temperature over the past 17,000 years. And what you notice is you got the temperature jumping up and down. I mean, if I were to go back to this graph here, you would notice that the global mean temperature is highly random and variable throughout the Ice Age cycle, where you got the temperature jumping up and down by more than 10 degrees centigrade, 18 degrees Fahrenheit, on time scales of just a few centuries. With a climate that unstable, it's impossible to engage in large-scale agriculture. For example, humans were around during the last Ice Age. They were making bread, but it was all on a very small scale because of the extreme climate instability in which they were having to deal with. Then we got the asteroid hitting in northwest Greenland. It's responsible for that sharp dip you see in temperature, where for 1,200 years the temperature dropped by 13 degrees centigrade, 20 degrees Fahrenheit. And what that did is it stopped the global mean temperature from going up to its normal maximum. So instead of going up to 5 degrees Fahrenheit above where it is now, it stopped 5 degrees short. And for the first time, there was a stable climate, and humans began to engage in large-scale agriculture. Now, where you see that purple line transition to a blue line, that's when human industry begins to take place. They call it the Neolithic Revolution. That's the first time humans engage in large-scale agriculture, and that's also the time when the rotation axis was at its greatest tilt, 24.5 degrees. So at the beginning of that blue line there, you got that tilt moving back up towards 22 degrees, and what that does is it cools the planet. And if you look carefully at that blue line, you see that it very slowly declines. The global mean temperature over the past 9,500 years got about 1 degree centigrade colder over that time period. Now, normally, it would have dropped by about 15 degrees. That didn't happen because human agricultural activity had a warming impact on the planet. So here you got the rotation axis cooling the planet. Human activity and the growth of our civilization worked in the opposite direction to warm the climate. And what's amazing is for the past 9,500 years, they've been almost in complete balance. The cooling that you would get from the tilt going back up to 22 degrees was perfectly balanced by the advance of human industry and agricultural activity. I mean, for example, the domestication of cows greatly increased the emission of carbon dioxide and methane into the atmosphere. The domestication of rice, especially the flooding of rice fields, pumped a lot more methane in the atmosphere. Those are greenhouse gases. They work to warm the planet. But what I find fascinating is the humans living 5,000, 6,000 years ago, or even 500 years ago, they didn't know anything about climatology. They didn't know anything about the tilt of the Earth's rotation axis. They were just doing the things that they were normally doing without any consideration of the astrophysical or geochemical consequences. But the amazing thing is it perfectly balanced what was happening in the astronomical cycles. Bottom line is, I don't think this is an accident. To get 3 perfectly timed and placed and sized asteroid collision events happening at just the moment and having human industrial activity proceed at the degree that it is, I don't think that's, I mean, one coincidence maybe, but you got literally multiple coincidences here that you have to explain. This to me, I think, is more evidence that we got the handiwork of God working with the physics of the solar system and simultaneously with human activity. Okay, text your questions. Or come to the microphone at the back. We're going to alternate between questions at the microphone at the back and questions that are being texted in. And incidentally, this is being live streamed, so a lot of the questions we're going to be taking will be from the live stream audience.
We have one question we'll start with from someone named Bill. Does not say where he is, but his question is. Oh, right there. You're taking credit for it. That's good.
All right. No,
No, I'll read it.
You can either text or go to the microphone.
If God is a creator of all and is all loving, then why did he create hell with no bail?
Hell with no bail.
That is entrapment. Everything makes sense if he didn't create everything, or if there is no place called hell for eternal suffering with no bail.
Okay, that's a very good question. And the question of bail presumes that the people want out of hell. There's no need for bail if nobody wants to leave hell. And what you see in the Bible is that we have a choice of where to spend eternity. We can spend it in heaven with God, or we can spend it in hell without God. You get your choice. And the people who choose had to have nothing to do with God aren't going to want to go to heaven. Heaven for them would be a worse place to spend eternity than spending it in hell. And that's why God has these two places. One place you get to spend eternity with him. Any other place you don't have to have anything to do with him whatsoever. And there really are people that want nothing to do with God and says, well, if that's the way you are, I've got a place for you. And you say, well, why is there torment in hell? Well, the reason there's torment in hell is because everybody else there also wants nothing to do with God. They don't want to submit to him. They want nothing to do with his moral standards. And the problem is those individuals tend to make life miserable for their fellow inhabitants. And what you see in Revelation 19 and 20 is that there are different levels of torment. And what's really interesting about the Greek word used there in Revelation for the torment in hell, it has the fundamental meaning of restraint. And so rather than thinking of it as torture, think of it as restraint. And also makes the point that different individuals get different levels of this restraint, making the point that some need more than others. And the text actually says that. In proportion to the evil they've committed here on earth, those individuals will be restrained more than those who've committed less evil here on earth. Some will need more restraint than others. I mean, we can think of some individuals. If I'm in hell, I think I'd rather have Stalin relatively more restrained than myself, because I know he's got the potential to make conditions a lot more miserable for everybody else. And incidentally, there's a flip side. In heaven, people get different rewards, again in proportion to the degree that they've submitted to God here on earth. So in that sense, I would argue that if you were to go to someone who's spent 1 trillion years in hell and say, hey, what do you think of this place? This is, well, it's not very pleasant. Would you like out? I definitely would like out. Well, I'd be happy to give you an escort to the kingdom of heaven on one condition. When you get there, you will need to go into a relationship with the creator of the universe and lovingly submit to that creator for the rest of eternity. And an individual is going to say, please don't make me go. I'd rather spend eternity in hell than be forced to submit to the authority of the creator of the universe and relate to him as an individual for the rest of eternity. So I think that helps. If people want more insight on that, I did write a book called Beyond the Cosmos, and I think it's chapter 14 of Beyond the Cosmos, where I got a chapter on how God expresses his love even to the individuals in hell. And basically I make an analogy of what has happened in certain prisons here on earth where people have failed to restrain the prisoners. In fact, I could even tell you a personal story. My son was almost murdered by some people who actually wound up murdering his friend. And while they were awaiting trial, they wound up doing serious physical harm to their fellow prisoners. And they eventually had to put them in a special cell where they couldn't no longer do any physical harm. I mean, at the court trial, I got to see photos of what they did to their fellow prisoners. And it's like they almost killed their fellow prisoners. And so, again, I think there's a reason why we've got different kinds of prisons, ones with more restraint than other restraint, again, because of the individuals that are there. Hopefully that answers your question. If you got a follow-up, feel free to come to the microphone or text another question, because, I mean, that's a very deep question. I gave a brief answer, but I'm well aware that a brief answer doesn't do justice to the depth of that question.
Yeah, we do have one question. No, but go ahead, and you're going to
Yeah.
need to get in line anyway.
Yeah, you're going to have to get in line anyway. Okay.
Yeah. Go ahead, at the microphone.
Can you hear me?
Yes.
Okay. Thank you, Dr. Ross and Ross. Albert Einstein in 1930 theorized the universe followed an eternal series of oscillations, each beginning with a big bang and ending with a big crunch, so to speak. In the interim, the universe would expand for a period of time before the gravitational attraction of matter would cause it to collapse back in and undergo a bounce. Could you answer me in layman's terms, please? Thanks. How do we know, if we do, that is, that the various cyclic or oscillating cosmological models are not true? You know what I'm talking about here?
Yes, I do.
Yeah. So I found 4 different models. I won't list them because I know you know them. One is by Roger Penrose. It seems like they're still investigating this, but I'm sure you have your view on this. And what is it, please?
Sure. If you want the details and the documentation, you'll find it in the 4th edition of The Crater and the Cosmos. In fact, that's one of the books we're giving away in the drawing. So you'll see a couple of chapters that address those questions. And you mentioned Roger Penrose's model. He did propose many years ago the idea that maybe there was a previous contracting phase of the universe that somehow transitioned into our current expanding universe. But in a lecture he gave at Cambridge University in response to a question, which I cite in the book, people asked him, do you still think this model is viable? And he basically said no. He says, because trying to join the geometry of a collapsing universe to a geometry of an expanding universe is equivalent to trying to join the singularity of one black hole to the singularity of another black hole. Mathematically, it's conceptually feasible. Physically, it's impossible. And and by the way, that's kind of what wormholes are all about, where you got kind of one black hole joined to another black hole, where you can go from one space-time realm to another space-time realm. And it's presumed that you can actually join together the two singularities. Mathematically, it's possible. Physically, the possibility that they would ever perfectly touch is 0. The possibility that even if they did touch, it would be stable is also 0. So mathematically, you can conceive of it. Physically, it's impossible. The same thing is true of trying to join the geometry of a collapsing universe to the geometry of an expanding universe. And as Roger Penrose has pointed out, all of these models where they propose a contracting phase previous to the expanding phase are speculation. They're not based on experiments or measurements or observations. It's people simply speculating, well, since we don't know what happened before the beginning of the universe, maybe we can speculate. And so that's what they do. And, people tell me, well, since I'm free to speculate, I don't have to become a Christian. Well, that's not a good way to run your life, I would argue. In terms of who you decide to relate to, who do you decide to marry, I would say it's really a good idea to base your decisions on observations and experiments rather than on speculation. So I'm just encouraging people to be philosophically consistent. So but the bottom line is you can never get away from speculations. In fact, one of the analogies I put in the Creator and the Cosmos is I could speculate that my wife of 40 years really isn't a physical being. It's conceivable that she's simply a sophisticated three-dimensional hologram that's being controlled by somebody from beyond the universe to make me think that she's a human being. That's possible, but all the experiments and observations tell me otherwise.
All right, Hugh, we have one more question from cyberspace. This is from Ruth, who is here in the audience. Is the planet warming, and is climate change as bad as people make it out to be?
Okay, is the planet warming? The answer is yes. And there's a big debate on climate global warming. But what I notice is in the past year and a half, both sides are now agreeing warming is real. I mean, the temperature measurements are there. You really can't dispute the data. And I think what caused people to dispute global warming reality in the past is they lived in an area where the global warming models predicted that you would get either stability or cooling. It's the global mean temperature that's going up, not necessarily the temperature where you live. But for example, I'm from Canada, and Canada is experiencing the most dramatic global warming of all the regions in the world. Literally, the northern Canadian territories are warming 5 times faster than the global mean temperature. So parts of the planet are warming a whole lot more, but other parts are actually getting cooler. It's the global mean temperature that's going up. So where the debate is what's causing the global warming. The big debate is to what degree is human activity responsible for the global warming. And if I were to go back to this curve, what you see is that human activity prevented global cooling by about 15 degrees centigrade. The cooling only went down by 1 degree. Now, if I were to expand this graph, you'll notice at the very end, the temperature jumps up 1 degree centigrade. So it took 9,500 years for the global mean temperature to very gradually drop down by 1 degree centigrade. In the last 70 years, it's gone up 1 degree centigrade. So all the cooling we had over the past 9,500 years literally has been erased by what's happened in the last 70 years. Now, the debate was, well, is it all carbon dioxide's fault or is it something else? And we now know that carbon dioxide is a factor. I mean, if you look at carbon dioxide measurements in sea cores and ice cores, you always see a strong correlation between the amount of carbon dioxide in the atmosphere and the global mean temperature. So there's no doubt that when you put carbon dioxide in the atmosphere, it warms the planet. There's also no doubt that there's a lot more carbon dioxide now than there used to be. Last measure was 407 parts per million in the atmosphere. If you're talking previous to the Industrial Revolution, it was around 275 or 280 parts per million. So yeah, we increased it by a significant amount. However, methane's gone up, nitrous oxide's gone up, chlorofluorocarbons have gone up. Those are also greenhouse gases. Carbon dioxide's not the only factor. It's the biggest factor, but methane also is a significant factor, as are nitrous oxides. Moreover, one of the big factors warming the Canadian North is the deposition of carbon dust. It's black, and when it falls on snow and ice, instead of that snow and ice reflecting sunlight with 60% efficiency, it reflects it with only 30% efficiency. And most of that dust is coming from coal burning in India and China. And so what we now understand is the causes of global warming are a lot more complicated than we thought in the past. However, I can tell you that the natural phenomena, namely what's happening with the tilt of our rotation axis, it's continuing to cool the Earth, as is the change in the eccentricity of Earth's orbit. It's also in a cooling phase. So if it wasn't for human activity, we should be deep in an ice age right now. In fact, one thing we can say is because of human activity, we've delayed the onset of the ice age by a good 5,000 years. That explains why this interglacial is the longest interglacial in the history of the ice age cycle. We basically have extended it by human activity. But I would agree, over the past 70 years, we're overdoing it. But I would also argue there are ways we can correct the overheating of the planet that would actually boost our economy, not drag our economy down. That's what's really driving the political debate. You go one side saying, we all have to stop driving cars. We need to shut down our factories. And we need to have basically stop eating meat and all these other things. The problem with those kinds of suggestions on how to solve global warming, it doesn't take into account that human beings are sinners. Because we're sinners, it's going to be very difficult to legislate something that actually hurts your pocketbook rather than boost your pocketbook. And so I'm recommending that we simply accept the fact human beings are selfish and they're going to be prone to cheat. If you ask them to make draconian economic sacrifices, we're better off with solutions that actually put more money in everybody's pocket and at the same time cool the planet. And there's actually a number of fairly straightforward ways that we can do that very thing. So.
Ram, I'm going to take your question in one moment, but I'm going to interrupt it with a question of my own, Hugh, as a follow-up to that. As those of us who are people of faith and people in general, is there a way that each of us individually should be living our life differently because of global warming, in your opinion?
Well, that's what Al Gore would like you to do, is stop driving your car, don't eat meat anymore, and basically trim back your standard of living to what it was before the Industrial Revolution. Frankly, I think that's going to be very hard to legislate. And even if all of us Americans do it, what guarantee is that other nations will follow suit? And because we're basically sinners, I think cheating will go completely out of control. That's why I'm recommending we come up with solutions that actually improve people's economic well-being rather than degrade it. I'll give you a couple of quick examples. In fact, one is going to be printed this Monday. I put out a blog every Monday, and the blog that's going to come out tomorrow basically is making the point that research is now showing that it's not only sperm whales, but baleen whales that cool the climate, mainly because they pull greenhouse gases out of the atmosphere, which seems like an enigma because they breathe out carbon dioxide. However, they feed on extremely iron-rich food, and they defecate that as soluble iron into the photic zone. And what they're now discovering is that thanks to the whale populations beginning to recover, we have way more phytoplankton in the oceans than we used to have. And guess what phytoplankton do? They draw greenhouse gases out of the atmosphere. And so they're pulling huge amounts of greenhouse gases out of the atmosphere. And the economic benefit is if you got more phytoplankton, you got more zooplankton. If you got more zooplankton, you got more fish. If you got more fish, that means you can have cheaper fish on your dining room table than you used to have before. Because fish stocks have been declining because we've been overfishing the oceans. One way we can fix that, bring the whale populations back. And by the way, the whale populations are still far below what they were before the Industrial Revolution. So bringing them back, I think, would be a good thing. And incidentally, I discovered there's a tourist industry for whales. People like to watch whales. And so you get an economic benefit there. You get an economic benefit from the fish stocks being restored. And you get to pull a lot of greenhouse gases out of the atmosphere. If you want to see several more solutions, you can get the book Hidden Treasures in the Book of Job. I described several there. I'm going to be describing several more in the book I'm working on right now.
Thank you, Hugh. Ilram, you have a follow-up?
Well, I guess just wanted to get more detailed in that question. Again, about hell having no bail, because I, from my own experiences, like from experience comes truth, and going deeper into that, like for me, I want to believe in a God that has created everything and is all loving. But this hell issue, for me, has always been a problem with me, because if me wanting to believe in Jesus or becoming a Christian, they're saying, if I don't, like you said earlier, if you choose to go to heaven, then you have to pretty much obey the Creator. You're pretty much a slave. And then people are saying, no, I don't want to do that. I'll stay in hell. But my question is, if you are a good person, and this is a common question, it's like, if I follow the Bible to the T and I'm a good person, it doesn't matter. It's like, you have to serve Jesus Christ. You have to worship him in order to go to heaven with him. And recently I would talk to these people, and like you said, there's different levels of punishment in heaven, which I've recently heard. Before, it's always, no, it's heaven or hell. That's it. It's like, no matter what, it's like, you can be great, but then you don't believe in Jesus Christ, you're going to hell. A mass murderer does the same type of, is like killing people, that you get the same punishment. But it's different. I'm thinking differently now from what you said, now that they said there's different levels of punishment. But to me, so I agree with you. I think it's a choice. But again, in the Bible and what people say, it's like, it's not a choice. It's like, I want to believe, but I have a fear of worshiping something, because to me that's selfish. And like you said just now about all of us here on this planet, we're sinners, we're selfish, and I believe we are born selfish to find someone or something to be selfless for, and that's our journey in this experience. But to say you need to worship somebody is the most selfish thing that I can think of. And so for us to give that permission for a God to be that selfish, I have questions. I worry about that.
No, that's really good. And the Bible makes the point that we are spiritual beings, and spiritual beings are compelled to worship. So it's not an option for us not to worship. We're all worshiping something, whether it be a little white ball in a green patch of grass that we chase with a scepter, whether it be ourselves, whether it be God, whether it be Satan, whether it be a certain sports event that we watch on TV. We're all compelled to worship. We got a choice who to worship. And the Bible basically says that we're here on earth and we get to go one direction or the other. You mentioned the point about slavery, and worship is slavery. You're basically enslaving yourself to, an addiction or a person. I mean, that's what it is. But the point is, who are you going to be a slave to? And the Bible, the Apostle Paul particularly, makes the point that in this life here on earth, we're moving towards slavery towards Jesus Christ or slavery towards Satan. And while we're still alive, we're kind of in between. But by the time we're at the point of death, we're either in one camp or the other. Nobody dies sitting on the fence. And so this idea that somebody would be sent to hell and regret going there and saying, gee, if only I had done this and that, I wouldn't be here. It's like no one's going to have regrets when they're in heaven, saying, gee, I really didn't think this life of submitting to Jesus Christ was going to be like it is. Please send me to hell. That's not going to happen because nobody dies sitting on the fence. So you're going to want to stay in heaven for all of eternity, or you're going to want to stay in hell for all of eternity, because through the course of your life, you've made that decision. Now you'll find a chapter in Beyond the Cosmos where I describe what Paul's talking about in terms of our movement towards slavery towards Jesus Christ or slavery towards Satan. He makes the point that we think we're in control of our fate. We're really not. We are in control of our free will. However, the way our free will works, when we choose in a direction of obedience to the Creator of the universe, what that does is it strengthens the will of the Creator in our life. and it weakens the will of the supernatural being in rebellion against God, the will of Satan. But if we choose to rebel against God, it has the opposite effect. It weakens the will of God in our life and strengthens the will of Satan. And the whole point is, if you continually practice rebellion against God, what that does is progressively strengthen the will of Satan in your life and weaken the will of God. And it reaches a point where you, by your own free will, have chosen to make the will of Satan in your life so strong and so powerful, your own free will is not able to overcome that. And that's when you become a captive of Satan. And likewise, the reverse happens. If you continually say, hey, I want to learn who this God is, he seems like a wonderful person, I want to relate to him, I want to submit to him, and you keep making decisions in that direction, you wind up strengthening the will of God in your life to such a high degree and weaken the will of Satan, you literally become a captive to God's will. But it's something that you want. Likewise, the one who's choosing the other direction, it's something that they want. But it reaches a point, it's kind of like a vector diagram. And that's what I've done in Beyond the Cosmos, is show you a bunch of vector diagrams of what happens to your will, Satan's will, and God's will in the course of your life, and explains why the Bible says we're on a pathway to having an eternally secure relationship with the Creator of the universe, or an eternal relationship with the supernatural being in rebellion against God. And God will keep you alive long enough until you're in one camp or the other. And so some die young, some die old, but nobody dies sitting on the fence. But that's one reason why we speculate, because while we're alive, we're moving to one direction or the other. And so we're not totally in one camp or the other. So I think that explains why people say, well, I mean, I can't imagine God putting that person in hell for all of eternity. Well, they're not at that point yet. There's still a possibility they could repent. The other thing you mentioned, I think, is worth commenting on, about people doing a lot of good deeds and the bad deeds. And you see this addressed in the book of Ezekiel, chapter 18 and chapter 32. Where Ezekiel is addressing a lot of rebellious Jews. And these are religious Jews. And these are religious Jews that are really proud of all the good stuff they've done. But they've lived a life of rebellion against the Creator of the universe, trying to steer people away from the truths that you see in the Bible. And what Ezekiel points out is that on Judgment Day, it's not going to be a weighing of good deeds versus bad deeds. Yes, there will be all your bad deeds on one side and your good deeds on the other. But then the eternal judge will ask you the question, have you chosen to submit your life to the authority of Jesus Christ, or have you chosen to rebel against the authority of Jesus Christ? And if the answer is, I've chosen to submit, God takes those two sides and says, here's all the evil you've done, I'm going to dump it, and there's nothing left. I'm going to judge you based on what's on the other side alone. And based on what is there, you will get your proportionate reward. On the other hand, someone who says, I want nothing to do with God and I want to live a life of eternal rebellion against God, God takes those two sides and says, all the good that you've done, it gets dumped. There'll be nothing left. And what's interesting in those two chapters in Ezekiel, the Jews that Ezekiel is explaining this to, they are very angry and say, no way. I want to be judged good deeds versus bad deeds. I don't want to be judged the way you say God's going to judge me. And Ezekiel points out, look at the motives behind those good deeds. Were those motives designed to bless other people, to bless God? Were they done in submission to God? Or were they done as an expression of personal individual pride? And he says, if that's the case, then they're really not good deeds. And if I were to do it your way, I would have to judge you against all those good deeds you've done, because the motive behind those good deeds was actually evil and not good. But I'm going to do you a favor. Rather than count what you think are good deeds against you, I'm going to simply ignore them. I'll erase them. I'll only judge you what's on the other side. And so in one sense, it's a blessing to those who choose to spend eternity in hell, not to have torment in proportion to the good that they've done. God just simply chooses to forget it. But likewise with the person who chooses to submit. And it counts. Even if someone has lived a life of rebellion against God for the first 60 years of their life, but in the last 10 years says, what I did was wrong, and they repent and say, I'm going to turn away from that. I'm going to live the rest of my life in submission to the Creator. God says, in that case, I will forget everything you did during those 60 years. It will be erased. It will not count against you because of your decision to turn your life around and to submit to the authority of Jesus Christ. So that too is described in Beyond the Cosmos.
Okay, thank you. I have a follow-up, but I'll have him
Okay,
ask his
yeah,
question.
you can
Thank
keep
you.
coming back.
If it's okay, Hugh, Ilram, I'd like to take a shot at your question too. But before we do, it's a couple of minutes after noon. Let's get those cards filled out. And if somebody, one of the class members, could pass those, we could get those collected and bring them up to me, we'll do the drawing. But Ilram, I want to, if you don't mind me taking a shot at your question, the way you structured the question was, it makes it sound like the Christian life is mostly about like a set of rules that we got to follow. And if we follow those rules, then God's going to be happy with us and we're going to go to heaven. And that's not how I see the faith at all. I'm by nature a pretty selfish and rebellious person. And Jesus said the greatest commandment was to love. The greatest commandment is to love other people and to love God first and love other people. And to the extent that we allow Jesus Christ into our being and let him do that through us is going to determine where we wind up. It all boils down to that. So the good deeds that we do are based on our love for God and our love for other people. And I know, I was raised in a Christian home, and for the first 30 years of my life, I thought it was a list of rules. I realized that when it becomes about love, it makes the faith really, really, really exciting. I wake up in the morning and I say, Lord, how can I help other people? How can I care about people? What do you got for me today? And he provides these amazing opportunities for me to care about people. And I know that when I'm not thinking about him and I'm in my own selfish ways, I'm miserable. And I realize that without Christ, I cannot do what I want to do. I can say I want to care about people, I want to love people. I'm not capable of it. And so Jesus says he will do that through us if we let him. And that makes my life worth living. It gives me a reason to live. It makes it fulfilling. I know what my purpose is. And really what worship is for me is just saying thank you. I'm living in like this eternal state of gratitude to the creator of the universe who actually wants to partner with me in helping the world. And so I'm just saying thank you constantly, for the people here, for the weather outside, for the fact that he created me and he cares enough about me to actually want to express himself through me. So I hope that helps. That's kind of how I see it, rather than this sort of random list of rules that you either follow or you don't, which, put you in heaven or in hell.
Follow-up questions. I agree with you, but I have follow-up questions to all that. So
Okay.
I'll let them.
All right. Thank you for letting me do that. So let's get the cards passed up, and we'll do a drawing here. I have one card so far.
I don't understand.
Someone's going to win.
Somebody's going to win all three.
I don't understand his answer.
I'd rather have a conversation with somebody.
Thank you.
Happy to talk to you about that.
All right. Is there anybody else? Last call here. Anybody else wants to put their name on a card? All right. Let's do this. Pick a card, Hugh. Freddie Guzman. So since you're first, you get your choice of which one. Very good.
Thank you.
Thank you. All right, Hugh. Basil Anton. All right. Thank you. And one more. And Derek McMaffin? Oh, Derek, yeah. So you get your choice of this or this or this. There you go. Congratulations, everybody. Thank you for doing that. All right, now I got to catch up here. Here's an interesting question, Hugh. What are your thoughts about nuclear power? Do we have the ability to use it safely?
Nuclear power. Well, there's a lot of options with nuclear power. But to put this in context, you release a lot less radioactivity to the environment with nuclear power in any context than you do by burning coal. Coal is loaded with uranium and thorium. And when you burn it, you release it to the environment. So in that sense, nuclear is safer for the environment than coal. But there are different options with nuclear. There are breeder reactors that potentially are much more efficient than the standard U-235 reactors that are out there. And what a lot of my colleagues are working on in physics is coming up with nuclear fusion reactors. I remember when I was a student back in the 1960s, they were saying, certainly by the end of the 19th or 20th century, we're going to have fusion power reactors. Well, we're still thinking it's going to be the end of the century, only we're now talking the 21st century instead of the 20th century. So, but there's been a lot of progress, but that would be the real benefit if we could take hydrogen and fuse it into helium and get electricity from it. That's how the sun produces energy. And so how can we copy the sun and get energy that way? And if we literally go from hydrogen to helium, there's no radioactive issue there. However, I can tell you the fusion reactors they're working on now is deuterium and tritium to make helium. And tritium is a really nasty radioisotope. So it's not as clean as we would like. But nuclear energy really does have potential. And but the advantage is you're not releasing greenhouse gases. So that could be an option, but they're expensive. And you've got to have, incidentally, what's new is, remember that big accident they had in Japan with a nuclear reactor? Fukushima. They're now working on robots that can go in and take care of problems when they have a nuclear accident. Because that was a big problem with Fukushima, is like, there's a lot of radioactivity in there. There's no way we're sending a human being in there to turn the right valves. But what if you could send a robot in there to hit the right buttons and control the valves? So they're actually working on that right now. And they've made a lot of progress. We're almost there.
Great. We'll take another question at the microphone.
Confused about your answer to my question. How do we know that the cyclical oscillating universe doesn't exist? I'm a layperson. Maybe I just didn't understand your answer, but I'm still confused about your answer. Thank you.
Okay, well, let me try to simplify a little bit, is that oscillating universe models are actually what you see in Hindu theology. The Hindu Vedas for thousands of years have taught that the universe goes through cycles of birth and rebirth, and actually says it cycles with a period of 4.32 billion years. And I remember reading that before I became a Christian, saying, well, we know the 4.32 isn't right. The universe is a lot older than that. but also recognize that in order to have a universe rebound, you need some mechanism to turn it around. And the problem there is the entropy of the universe is at least 100 million times too high to allow for any possibility of a mechanism to rebound the universe from a contracting state to an expanding state. What's happening now, which is what I was responding to in your question, is you've got theoretical physicists who are saying, well, let's not worry about the entropy issue. If we're talking about the beginning of the universe, where you got a space-time beginning, they're speculating things like maybe the arrow of time reverses. Instead of time going forward, time goes backwards, and maybe we're dealing with completely different laws of physics. So the contracting phase of the universe would be one where thermodynamics wouldn't operate like it does now. But that again complicates the issue. How do you join a universe with a different geometry with our universe that's expanding? That's how I responded to your question. I say you got a geometry problem. Trying to join the geometry of a contracting universe to expand a universe is fraught with enormous mathematical difficulties and physical difficulties. But there's another issue. How do you join a universe with different laws of physics with a universe with alternate laws of physics? So if you're going from a universe where you have thermodynamics non-existent or operating in a very different way, how do you seamlessly join that to a universe where you got different laws of physics? And my whole point is you can speculate all you want, but you got to make the model work. And so physically, how do you get from that contracting phase to an expanding phase? And all the physicists that have been speculating along these lines, incidentally, they all admit that they're doing this to avoid the theological implications of an agent beyond space and time that creates everything. But they also freely admit that this speculation is not a theoretically worked out model. There's still huge issues like I've been discussing. And what I describe in the 4th edition of The Creator and the Cosmos, you're really dealing with physical impossibilities. And the bottom line is, base your faith on what you can measure and observe. And 100% of the experiments and the observations tell us we live in a universe with a real beginning, including a space-time beginning. Now, there's been speculation that maybe we can escape the conclusions of the space-time theorems by appealing to the quantum gravity era. Again, it's an attempt to say, well, maybe in this very early era of the universe, the laws of physics work differently than what we think. But there's actual new measurements that are beginning to penetrate the quantum gravity era, and what they tell us is the space-time theorems indeed hold all the way back to the very beginning of time itself. Bottom line is there's no escape. There really is a beginning of space and time, and there's a beginning of space and time. There really is an agent who created space and time.
We've got so many people at the mic. I'm going to take break pattern here and take one more question from the mic. Go ahead.
Hello. Yeah, pursuing this climate change thing just a little bit more, I had noticed that all the way at the zero end of the curve you had up there, that it does start to make a slight uptick, and you referred to the fact that that 1 degree has been wiped out in the last 70 years. Now, the last I've been hearing from you was that we really scientifically do not know whether humans have had the dominant effect on climate change or it's been mostly natural. However, it sounds like this is pretty strong evidence that it's humans really are responsible there,
Right.
and therefore we have to take responsibility for that. Could you comment a bit on further?
Yeah, that's correct. And especially when you take into account the wide range of human activity. The fact that we've domesticated rice and cows, and we're not just putting carbon dioxide in the atmosphere, we're putting nitrous oxides, methane, and hydrofluorocarbons into the atmosphere as well. So incidentally, a few years ago, they legislated against hydrochlorocarbons for refrigerants, and they replaced them with hydrofluorocarbons fluorocarbons, not hydrocarbon fluorocarbons, but hydrofluorocarbons. And what they've now discovered is they're better, but they also are a greenhouse gas. But they're a greenhouse gas that's only 3 times, it's less than 3 times as efficient in warming up the planet than what we had before. But starting this year, they're going to ban that refrigerant as well. And so you're going to have to change the refrigerant in your car again, because they now realize, yeah, the substitute is better, but it's not good enough. And there are substitutes we can use that would have a 0 impact on warming the climate. So they're being legislated in Canada and the US and Western Europe this year, and by 2025 it'll be worldwide. So things are happening, but yeah, human activity is the primary cause, mainly because we now recognize that the natural phenomena are actually in a cooling phase, not a warming phase. So given that the natural phenomena, these astronomical cycles are both in a cooling phase rather than a warming phase, that again puts the attention on human activity. However, we can't say that human activity is 100% responsible. There could be other issues, but yeah, we're certainly the dominant factor.
Thank you. Hugh, this is from Kerry here in the audience. He says, God has provided this wonderful blue bubble called Earth for us. Is it disrespectful to him to look to moving to other planets? Should we be content to stay where he has placed us? Is there a biblical perspective on this?
Well, a biblical perspective is God purposely made us curious and made us deeply curious. I think it's part of our spiritual being, is our curiosity. And God wants us to express our curiosity, to learn as much as we can about everything we can physically, emotionally, intellectually, spiritually. So I think he's in favor of us exploring the universe and learning as much as we can about the universe. However, I can tell you as an astronomer, everywhere we look, conditions are far more hostile than they are here on Earth. Trying to form a colony on Mars, frankly, I think it's out of the question. In fact, I wrote a blog a couple of months ago making the point that if you were to try to travel from Earth to Mars, your digestive tract gets destroyed. And so arriving on Mars with a destroyed digestive tract is not a very good option for trying to form a colony there. Yeah, what they've discovered is they did experiments on mice, and mice have digestive tracts that are very good analogies to human digestive tracts. You know, mice and rats can eat anything, just like we can eat almost anything. Their digestive tract is very similar. And so they expose these mice and rats to the kind of radiation you would experience outside the magnetosphere of the Earth. And what they discovered is, if you kind of translate the analogy into human beings, an astronaut would experience really serious digestive disorders after 3 months. And after 6 months, they're likely to be dead. But in 3 months, their digestive tract will be so disabled, they're not going to be able to function. I don't know whether you've ever had a bowel disorder or a stomach disorder. I mean, sometimes the pain can be really excruciating. Just think of having that pain nonstop, day and night. You're not going to be able to do anything. All you're going to be thinking about is how much your stomach hurts. So, but yeah, I wrote a blog article on that just a few weeks ago, so you can check that out and see the citation. But the bottom line is travel outside of the magnetosphere is not an option. So that alone, I think it kind of forces us to stick to planet Earth.
Sounds like it.
Although I do think it's possible that we could build a spaceship inside the magnetosphere, that we could have, quote, a space colony. So, you know, basically building an artificial planet. I think there was a movie, wasn't one of those Star Wars movies where they had kind of a little artificial planet that they used to kill other planets? I forget.
Yeah, the Death Star.
The Death Star, that's
Yes.
it. Well, we could actually build a life star instead of a Death Star. Basically build an artificial planet that you got to have a bunch of people living on, but you need to keep it inside the magnetosphere of the Earth. That explains why we can keep people alive in the space station, but we're not going to be able to keep people alive if we get outside of our magnetosphere.
Very good. Thank you.
Hello?
There we
Okay.
go.
Hi. What is your take on AI in regards to science and religion?
Good question. My colleagues, Fazal Rana and Kenneth Samples, have just finished a book called Humans 2.0 that addresses artificial intelligence and the transhumanism movement. Their whole focus was this idea maybe we could build superhumans by integrating humans with these advanced computers and advanced software where we could do things kind of like Superman, that kind of thing. And their book is basically making the point that there really are hard biological and physics limits to what we can do to improve the human body. And what we're not failing to recognize is that the human body has been designed to do a wide variety of activities. So where these advances could really help is enable you to do one thing better than other people can do. But it comes at a cost. We're not going to be able to do other things as well as other people can do. But my colleagues are also making the point that this is something we need to encourage, because after all, there are a lot of human beings that have significant disabilities. So for example, if you've lost an arm, they're now working on technology where they can give you an artificial arm that's actually connected to your brain so that your brain can control that artificial arm. The technology to do that already exists. And so we're going to see some really amazing prosthetics coming out within the next few years. So that's the benefit of this transhumanism movement. But the idea that we could make humans that could live for all of eternity, you're running into hard limits with the laws of physics to make that happen. And although there's one really radical idea out there where they can now take your head and transplant it to a body. So for example, if you are a quadriplegic where your body is just not functioning, there is now the technological feasibility of actually giving you a full body transplant where someone dies in a motorcycle accident. You know what they call people who ride motorcycles without helmets? They call them organ donors. But now you got the possibility where you could take someone's entire body and fuse it to someone's head. But the other way of actually transplanting brains, I don't think so. Although when I was mountaineering this past summer, my mountaineering guide was telling me, he says, the technology's around the corner where we're going to be able to transplant brains. But of course, there's a different cost on what kind of brain you want. If you want an Einstein-type brain, you're going to have to pay a lot more money. But he says the most expensive brain of all will be a mountain guide's brain because it's never been used. So, but yeah, what I'm looking forward to is artificially intelligent machines that can search databases way better than they can right now. I mean, there's a lot of benefits, but they call this book on transhuman. The book is going to be called Humans 2.0. And the whole point is the quest to make a machine that's actually conscious like we are. But what they're discovering, what a lot of this new book is all about, is the fact that there's a lot of science telling us consciousness is not a physical entity. And it's basically making the point, we human beings are not only physical, we have a non-physical component that can't be explained by chemistry and physics. And that's our consciousness. That's the spirit within us. And the whole point is when our physical body no longer operates, you still exist. Because you have a non-physical component living within you. And it's that non-physical component that actually controls the hardware of your brain. Your brain really is a good analogy for a very sophisticated computer. But notice how your computer works. It takes a human being to interface with a computer for the computer to do anything worthwhile. Likewise, it takes your spiritual consciousness integrating with your brain to make the brain do anything that's worthwhile. And eventually, we're going to get a piece of hardware that will not break down or wear down. Because, the older you get, the more of your brain begins to decay and erode away. Some of us may have noticed that already. And but eventually, we are promised that we're going to get a physical body where nothing erodes, nothing decays.
Thank you. We have a good text question here. Hugh, if you had time enough with someone to make only one brief apologetic argument for the existence of God, what would it be?
Well, I've been asked that question a lot, and my answer is, before you answer that kind of a question, ask questions. So when I engage someone who's not a Christian, total stranger, I try to find out what kind of individual they are, because I'm going to answer that question in a different way depending on the individual I engage. So there's no one pat apologetic argument. I need to find out from the individual what is their issue, what is their barrier, and then I'll answer that question. So, it'd be easy to say the resurrection of Jesus Christ bodily from the dead, but I've run into a lot of unbelievers for whom that's not the real issue that's stopping them from becoming a believer, in which case I need to come up with a different answer. Bottom line is, you need to have a tool chest with lots of tools in it, because every human being you engage is different from every other human being you engage, and you won't find out if you don't ask questions. And by the way, asking questions isn't that difficult. I found that most people I meet love to talk about themselves, and so asking them questions is a good way to get a conversation going.
Norm, you have a question?
Yeah, you may have touched on this previously. I think you have, but we talk a lot about the beginning of the universe and the birth of it. And I'd just like to hear your response, either how you'd answer this, either for or against, is that the birth of the universe primarily from a quantum fluctuation. What are the arguments for and against that?
Well, it depends what kind of quantum fluctuation. The real debate, and you'll see this covered in the 4th edition of The Creator and the Cosmos, the debate today is not over whether or not quantum gravity is real. People do accept that the first 10 billionth of a trillionth of a trillionth of a trillionth of a second of the universe, quantum mechanics has as big a role in the dynamics of the universe as gravity does. But nobody has a workable quantum gravity theory yet. But the way it affects cosmic creation models is the size of the quantum space-time fluctuations. And so the quantum space-time fluctuations in the quantum gravity era are small. It's going to have zero effect on whether or not there's a beginning to the universe. But there are physicists, some living just a few miles from here, that are speculating maybe the quantum space-time fluctuations are truly enormous. If they're truly enormous, then maybe the implications of the space-time theorems don't hold, because that would allow for radically different physics. However, what I wrote about in the 4th edition of The Creator and the Cosmos, we now have some observational evidence based on the images of distant quasars and blazars that are telling us the quantum space-time fluctuations in the quantum gravity era are not big enough to allow for an escape from the conclusions of the space-time theorems. And the point is, if you got big quantum space-time fluctuations in the quantum gravity era, what that does is it blurs the images of distant quasars and blazars at short wavelengths, and our observations detect no blurring. Now, there's another way we can actually probe the quantum gravity era as well, and that's to see what's happening just outside the event horizon of a gigantic black hole. And there is a worldwide effort now to map the event horizon of the supermassive black hole at the center of our galaxy. That has the potential to tell us what's really going on in the quantum gravity era. But my whole point in writing the book is this: the more we push back the frontiers of ignorance and learn what's going on, consistently, we've always seen that when we push back that frontier, we get more evidence for a creator God creating space-time, matter, and energy. It always goes in the direction of increasing evidence, never lesser evidence. And this is just simply the latest example. But will it close off all speculation? No. God always gives us room to speculate for the simple reason we're human beings confined to the space-time continuum of the universe, which means it's impossible for us to ever learn everything about the universe, which means there's always some little tiny space where you can speculate whatever you want. Just like there's a little tiny realm of space where I can actually speculate maybe my wife of 40 years really isn't a human being. But frankly, I've got a lot of evidence that she's a real human being.
Hugh, we have a text question. I keep seeing ads and news stories about how plastics are destroying the earth, killing animals, etc. How big of a problem is it really, and how can we fix this problem?
Well, it is a big problem, especially in places like India where there's no recycling or very little recycling of plastic going on. You can Google that, for example, and you'll see photographs of rivers in India where all you see is plastic on top of the river. Just huge rivers of plastic. And where's that plastic going? Out into the ocean. And when it gets out into the ocean, it gets broken down into little microparticles. Those microparticles are being consumed by algae and plankton and fish. And yeah, it does major damage to the biochemistry of those creatures. So it is a big issue. The way you solve it, recycle the plastic. It's worth money. And so notice here in the US, people don't throw away their plastic because there's money to be made in recycling the plastic. And that way it's not going under the ocean. Although there is some going under the ocean for the United States too. It's just not as bad as what we see in some countries overseas. But yeah, there's actually big patches of plastic in the Pacific Ocean. And you don't really see it because it's basically microplastic parts. But when it's microplastic parts, it does a lot more damage to the organisms out there than if you get a big plastic bottle out there that's not broken down. The big stuff is not a problem. It's the little stuff.
Thank you. John, go ahead at the microphone.
Often wondered why what I call the monster greenhouse gas that's 10 times worse than carbon dioxide is seldom discussed, and that's water vapor, which is has a tremendous heat-trapping quality,
Right.
but can be changed dramatically with condensation in clouds to a heat reflector. And since it's such a dominant factor in tropospheric warming, which may only be a part of the phenomena, it seems like ocean currents might have a lot more to do with it. The heat content is much higher in the oceans, but just wondering about why it is that water vapor is so seldom discussed, and why cloud formation might be a very key means that could be manipulated. I've talked to a man at JPL in atmospheric science. He says that there's a lot of gaps in the theory of cloud formation they can't explain, and it's very incomplete. He also said that all the computer models that predict global warming are inherently unverified, and they can say anything that you design them to say to predict, and that the data required to actually verify a model is just overwhelming. It's beyond comprehension. All the profiles in the troposphere of temperature and humidity and so on. But anyway, I'm just wondering about the issue of water vapor.
Sure.
And why that's ignored.
Well, it's not ignored. It is addressed in the research papers on global warming. And so they're well aware that it is indeed the dominant greenhouse gas in the atmosphere. The reason it's not getting the public attention is that it's not changing like the other gases are. It does vary, it goes up and down, but what you're looking at over the time scale of the last several million years is that the water vapor effect on global warming really isn't having a directional effect on either cooling or warming. So it goes up and down like this, but the bottom line is if you average it out, it's flat. And so that's why it's not getting the attention of carbon dioxide, where you can actually see that the carbon dioxide is going up in a particular direction. And also they've been able to see that carbon dioxide over the past 4 billion years has been going down dramatically. Only in the last little bit has it been going up. And when you notice that is that there's a tight correlation between the global mean temperature and the quantity of carbon dioxide or methane in the atmosphere. What I didn't say previously is they're still trying to determine the time constant. I mean, when you look at the cores, the sediment cores, the ice cores, you do see an extremely tight correlation between methane and carbon dioxide in the atmosphere and the global mean temperature. There is an issue, though, whether there is a time constant between the input of these gases into the atmosphere and the warming. Is it in the order of 10 years, 20 years? That's still being noted. However, we now have data that shows these greenhouse gases going up, and we got data showing the global mean temperature going up. So we now have taken these measurements for a sufficient number of decades that we realize if there is a time constant issue, it's a relatively short time constant. It's not centuries, it's decades or less, because now we got the data to see that the correlation indeed is tight across the board. But the reason that the water vapor doesn't get the attention, we don't see it doing a monotonic change with respect to time. It's basically a cyclical change like this, and it averages out to be flat. And incidentally, there's very good reasons why it must be flat. The geochemistry of the Earth, the only way you can change that is if you bring more water into the Earth or take more water away from the Earth. But the total quantity of water on the Earth, again, is a constant. Yes, there's water coming in, but there's water leaving, and they've been in balance literally for billions of years.
I just also curious that I've seen paleontological plots of carbon dioxide versus tropospheric temperatures that show that the carbon dioxide would increase about 50 years after ocean temperatures increased, and that sometimes it's explained that the carbon dioxide appears because the lack of solubility in the ocean water as the temperature rises.
Well, the oceans are a complicated factor because you also got organisms there that are absorbing carbon dioxide and releasing carbon dioxide. And the tropical oceans are a whole different animal than the high latitude oceans. And so that's another big part of the ongoing debate is what's going on in the oceans, what's going on in the terrestrial continental land masses. The thing about oceans, though, is that they stabilize the heat budget of the universe, or of the Earth, in the sense that notice that the variation in ocean temperatures is always a whole lot less than it is on the continental land masses. That's one reason why the temperature, say at Santa Monica, doesn't vary as much as the temperature here in Pasadena, because we're farther away from the ocean. The ocean has an effect of stabilizing the temperature. And so it's the continental land masses where you're really seeing the dramatic changes. And as you go to higher latitudes, you see a dramatic effect. And so there's a reason why the tropical oceans aren't getting the attention that the higher latitude oceans are getting, and especially the higher latitude land masses.
We're going to do one more question. Christy, go ahead. You're it. We've got about 3 minutes left. So for those of you who, both texting and in the audience, that didn't get your question asked, there was a lot of good questions, and I'm sorry, but again, we're doing this tomorrow night, so maybe we can start with a couple of the text questions from today. Go ahead, Christy.
Hi. I had a conversation just this morning with somebody who works with the Cal State system, and he's in administration, and he was saying how they're being trained to be more sensitive to the humanities and the people who take various social studies, women's studies, ethnic studies, you know, those type of classes. They really want to run you through those, and and he even asked the question, he's like, what about, you know, the 90% that are going through like business and engineering and pre-med and whatnot, the sciences? And he said, and they didn't give him a good answer. So we're in the middle of choosing not us choosing, our daughter's in the middle of choosing her college route. And with that, knowing that about the you know, getting some insight about the Cal State system. And she had a tour this last week at one of the UC schools, and we got kind of a similar thing. They want it, whatever you're going into, because she wants to go into sciences. She wants to do pre-med and then go into medicine. So it used to be, you know, if you're going into business, medicine, the sciences, you were a little bit, I don't know, not as in the fray of those hotbed agenda places. But the UC system, we got the same kind of input when we went on the tour, that they really want to, I mean, we're all for a well-rounded education, but they really want to run you through those things no matter what you're choosing to do. And that being said, we're like, well, gosh, we'd love to send her to a Christian university, not that they're all the same, but that's a tougher one for the sciences, the pre-med type of thing. I know Biola's working on faith and science.
Christy, what's your question?
No, I think I
want
got
his
the
input.
question.
Good,
Okay,
good.
yeah.
I want his input.
Okay.
Because, yeah, this is a growing trend in the United States university system, is to expose the engineering and science and STEM students to more of the humanities than they would normally get. I mean, I'm a classic example. I went through 9 years of post-high school education and took just 3 classes outside of math and physics. And one of those classes was chemistry. So, no, I did. I took a French class, an English class, and a philosophy class, but that was it. Everything else was math, physics, chemistry. So those were the days when they really wanted their STEM people to be really focused on STEM. But now there's a new trend where they want to make sure they're well exposed to the humanities. And this is even happening at Caltech. At Caltech, as an undergraduate, you must take a humanities course every single year. And so it's pervasive now, where they're trying to expose them. And the reason why is that they noticed that there's a cross-cultural barrier with people who focus exclusively on STEM and the rest of the population. And I actually got to see that personally in our paradoxes class some 30 years ago, because I invited 6 Caltech physics postdocs to come to our paradoxes Sunday school class. None of them were believers, but they wanted to see what the class was all about. And so they showed up in the class, and we were studying the book of Titus, and one of them walked up to the blackboard. We had blackboards back then. And he started filling the board with equations and says, we can do perturbative analysis on this passage in Titus. And he was assuming, of course, that everybody in the class understood perturbative analysis. And when I told him that, that was unique to people in this, he says, you mean nobody really knows what this is all about? It's like, and then what really made things interesting is another half hour went by, and 2 of the physicists stood up, and one of them said, look, why don't you defend that interpretation of Titus? I'm going to defend this interpretation of Titus. And they had a very vigorous debate in front of the class. And everybody in the class said, boy, those 2 really hate one another. And they said, no, we do this all the time. This is how we have fun. This is how we test things. And I remember there's one lady in the back, she was in her 90s. She got up and said, I think I'm in the wrong Sunday school class.
Mm-hmm.
And the whole point was there was a culture barrier. And so what's happening at universities today is they're really trying to make sure that they take steps to trying to help the STEM people actually communicate with normal human beings. So, but as someone who is very much into the STEM, I think it needs to go the other way as well, is that we need to help people who are not going in a STEM direction to learn a little bit about the culture that works with people in the STEM careers. Because the last surveys have indicated over 50% of high school students want to pursue a STEM career. So in that sense, I think it's important that we help the non-STEM people also to cross that cultural barrier, which means have them take a STEM course every year. I'd say let's make it work. If we're going to make the STEM people take a humanities course every year, why don't we make the humanities people take a STEM course every year and take one at a high enough level that they actually get to see how the culture operates. This whole perspective of rigorously putting everything to the test and actually encouraging debate and vigorous debate on these issues. Incidentally, I remember one time here at the church, several of us in the pastoral staff were working on a new doctrinal statement, and we were looking at the problem of men and women in ministry and divorce and remarriage. And so they put two of us who were physicists on the committee and two who were seminary-trained theologians. And the seminary-trained theologian says, I don't think we can handle this kind of debate you physicists are getting into. And he says, we're just testing the different theories. We're not angry at one another. We're trying to see whether this theory works or it doesn't work. But the level of fierce debate was something that was intimidating for the theologians. So there are culture barriers. Cross-cultural evangelism isn't just trying to go to a foreign country and speak to some primitive tribe where you don't know the language. It happens right here in America. So, but I'll tell you this much about your daughter. She needs to check out a variety of different colleges and universities. Some emphasize this cross-culturalism a lot less than others. So if she's the type that says, look, I really just want to focus on STEM, there are places where she can do that very thing. And hey, Caltech, you only have to take one course a year. Some places make you take 2 courses a year. So you do have options.
Thank you, everybody, for being here in the live audience and on the web for the live stream. We're going to continue this again in 154 right across the way here tomorrow night at 7 o'clock if you want more of this. And
that'll be live streamed, right?
And that'll be live streamed also, so we can continue with the questions. Let's say thank you to Dr. Hugh Ross.